Okay, so this is part, the multi-choice section of Exam 2, Northern Hemisphere, 2017. So obviously it's a multi-choice section. So I'm going to start off with question 1, x cubed minus 7x plus 5 on x squared plus 3x minus 4. We need to find the number of asymptotes. So x cubed minus 7x plus 5. Okay, so put it in. X cubed minus 7x plus 5. Obviously it's easier for you because I have them x squared minus plus 3x minus 4. X squared plus 3x minus 4. Okay, interactive, transformation, fraction, prop frac. Okay, that splits it apart for us. So we get, let's see what else we can. So we've got x minus 3, which is going to be one asymptote. And then we're going to have two asymptotes here if this factorizes. We could also try interactive transformation expand. Partial fractions, variable is x. Click OK. Okay, so that looks better to me. So we've got an asymptote at -4, one at 3, -4, one at 1, and then one on x minus 3. If you want to check, you can always go in, here's something I did earlier, go in and graph it, and you can see there's going to be an asymptote at 1, there's also going to be an asymptote at -4, and then we're also going to have an asymptote on that line, which we said was x minus 3. Okay, so we've got three asymptotes. Okay, next one, that equation where k is a real constant will represent a circle if and only if. If we want it to represent a circle, let's put it into circle form. So x squared plus y squared plus 2ky. If we have that, I'm going to get k. If I square it, I get plus k squared. We've got to subtract k squared, and then I've got plus 4 equals 0. X squared plus y plus k squared equals k squared minus 4. Okay, so that's circle form. What do we know about this? It's got to be greater than 0, otherwise it won't form a circle. So I'm going to have k plus 2, k minus 2 is greater than 0. Of course, you could do that on your CAS, but k is going to be less than -2 or greater than 2. Or you could just do a simple sketch. So there's 2, there's -2. When's it greater than? For all values less than -2 and all values greater than 2. Okay, the function for all real values from the real number set, k arc tan, so that's tan inverse, ax minus b plus c, k is greater than 0, c is greater than 0, a, b are real. The function will be greater than 0. So a tan graph looks like this. Normal asymptotes are between -pi on 2 and pi on 2. So that's our range. We want our range so that the graph is always greater than 0. That doesn't affect our range, that only shifts it left and right. This does. If we put a k out the front, our range will be -k pi on 2 to k pi on 2, because everything is going to be dilated by factor k from the x-axis. And then this it'll move it up k. So our range is going to be -k on 2 plus c, k pi on 2 plus c. Okay, it's always got to be greater than 0. This is our lowest value. So -k pi on 2 plus c has to be greater than or equal to 0. Because if it equals 0, this value isn't included because it's a square round bracket anyway. So from here, I get -k pi on 2 is greater than or equal to -c. Let's divide the -pi across and then the 2. So I get k is less than or equal to, because I'm dividing by a negative. I'm going to get 2c on pi. So k is less than or equal to What have I stuffed up? That has to be greater than or equal to 0. Negative c 2, negative k, k has to be, oh, I want c, so I stuffed it up, times your pi across, so you get k pi on 2 is less than or equal to c, so c is greater than or equal to pi, k pi on 2, which is this value here. Remember, it can be equal to, k can be equal to, or c can be equal to that value, because the bottom value, this, is undefined. Okay, next one, sine theta plus phi. So sine theta plus phi, that is sine theta cos phi minus cos theta, oops, cos theta sine phi, sine theta minus phi is sine theta cos phi minus, plus in this case because it's a minus there, cos theta sine phi. Okay, we know that if we add these two, or that's A and that's B, if we add them together, they're going to cancel. So I'm going to have A plus B is equal to 2 sine theta cos phi when I add them together. So I get sine theta cos phi is equal to A plus B on 2. Don't forget, I would have stopped working somewhere back here because I would have looked at it and gone, okay, when I add them, I'm going to get 2 times that, and then I divide that to the other side. So see if you can work it out quicker. You don't have to go through all the working, obviously, because it's multiple choice. Okay, here, if I want to put this into partial fraction form, I have to put it on something on x, something on the linear factor, so x minus 2, and then something on the squared factor. So c, and we have something that looks like that. Nice and easy. Okay, so if we have a look at this, this is a straight line, and it's a locus, so it's going to be equidistant from the 2 points. So if I was to plot z plus 2, so where's plus 2? That's at minus 2, there. The other one, z plus 2i. Get minus 2i. Okay, there it's equal distance, but then if I went from there and then to there, they're not equidistant. So that one's no good. So get rid of that. This is arg of z. Now, if it was a ray, it would start at the center and go up. If it had been moved, all that information would be in there, so it's not that. Z minus 2 means that we have been moved 2 to the right, because it's minus 2. Z plus 2i means I've gone down to 2. Okay, equidistant, equidistant, equidistant. We have a winner. Okay, what have we got here? Alright, I would probably look at the values on here, and that doesn't help us much. Okay, so I want to integrate this, I want to make it equivalent, so let's try a substitution. We know that sine cubed x is sine x 1 minus cos squared x. So if we let u equal cos x, then du dx is negative sine x. Okay, so in our integral, we've got to work out what u is. So if x equals pi on 4, cos of pi on 4 is 1 on root 2. If x equals pi on 3, cos of pi on 3 equals a half. So from here, we're going from 1 on root 2 to a half. I'm going to have sine x, but we know that sine x is du dx. if I put a negative out the front, because the negative times the negative would make it positive, so it's just replacing sine. I have got 1 minus cos squared x, which is 1 minus u squared, and then I have got cos squared, which is u squared, then dx. The dx's cancel, so we've got 1 on root 2, 2.5 negative u squared minus u to the 4, and then du is that there, minus 1 on root 2. Now u equals cos x, so it could be that first one. If we multiplied that in, the negative in, that would make this u to the 4 minus u squared, but they've also changed the terminals around, so it's not that one. If I've got a negative out the front, u squared minus u to the 4, negative, negative, du, cos u, it is b. Okay, this one here, I wouldn't bugger eyes around, I would just put them into the cas. So, we know it's between neg 2, 2, 2, 2. So let's go into the cas, diff equation, get rid of what's in there, get rid of what's in here, clear all. Okay, so our first one was x minus y squared. Sketch it. Now let's change our domain. Neg 2, 2, 2, neg 2, 2, 2. Okay, now this one goes up, so I don't think it's going to be that one. The next one I think was y minus x. Sketch it. Okay, that looks similar. However, if we're between negative 2 and 2, it doesn't look the same. And next one was y squared minus x squared. Okay, this one's flat around the center, curves up there. On the right hand side it curves down, goes up. The only thing is the bottom left hand corner, that doesn't look right, and neither does the top left hand corner, so that doesn't look right either. Y squared minus x, sketch it. Okay, so the left hand side is all going up, flattens out in the middle, goes down, goes up. That one I'm pretty sure it is, y squared minus x. Here I'm going to go y plus x, and that doesn't look like it at all. So we're going to go with y squared minus x. Looks good to me. Okay, the gradient of the tangent to the curve at any point pxy is half the gradient of the line segment joining the point P and the point Q. Okay, so let's say P is the point xy, and let's say Q is the point negative 1, 1. What's the gradient of that? It's going to be 1 minus x, or 1 minus y, sorry, on negative 1 minus x. We could take out a negative on the bottom, so y minus 1 on x plus 1, that makes more sense. Okay, what does it say? The gradient of the tangent pxy is half the gradient of the line segment joining those 2 points. Okay, dy dx is 1/2 of y minus 1 on x plus 1. So dy dx is equal to y minus 1 on 2x plus 1. Is that there? Y minus 1 on 2x plus 1. That looks like e to me. Okay, the solution to the differential equation in this can be obtained by, that top formula. Cos x plus y is cos x cos y minus sine x sine y. Cos x minus y is equal to the same thing but with a plus in the middle. If we add them together, we're going to cancel out our signs. So we're going to get, oh hang on, we subtract them. So if I did cos x plus y, subtract this, the cos x plus y, they're going to cancel. And then I'm going to have negative 2 sine x sine y. Okay, so that's what the top is. And then the bottom's e to the x plus y, which is e to the x, e to the y, and dy dx equals that. Okay, so let's bring our e to the y on sine y dy equals negative 2 sine x on e to the x dx. Is that anywhere? That looks the same as that. There's a negative out the front. Looks correct. Okay, two particles have position R1 is that, R2 is that. The particles will collide if the value of B is. Okay, they've got to collide, they've got to have the same position, and they've got to be there at the same time. So let's equate our x values. So 3 minus 4t squared equals 5t squared. From here we get 9t squared equals 3t squared equals 1/3. The other one, we have got t plus b equals t squared minus 1, t squared minus t minus 1 plus b equals 0. Okay, so we know t squared equals 1/3. So we can solve this equation for b, assuming t squared equals 1/3. So what was it? Let's go back out of here. I'm just going to use x because it's easier. So we had x plus, was x squared minus x, and then minus 1 minus, we'll call it y instead of b, minus 1 minus y equals 0. Interactive advanced solve for, we want to get y by itself, and then we do that, solve that given x equals 1 divided by root 3. So y equals, simplify, okay, negative root 3 plus 2 on 3. B equals negative root 3 plus 2. So negative 2 minus root 3 on 3, which is D. Okay, if u equals that and v equals that, the vector resolute of u in the direction of v. So it says vector resolute, not scalar. Okay, so we can do it on a cas. So u is 3, 6, negative 2. Okay, so I'm going to clear this out. So we want to put in our vector 3, 6, negative 2, and we want to dot that with our other vector, but we want the unit vector of that. So vector, unit vector, and then let's put our vector in. The other one is 2, 2, negative k. 2, 2, negative 1. So 2, 2, negative 1. We want to find the dot product of that. Calculation, no, vector, dot product of those two things. Okay, and then we want to times that by the unit vector of this thing. So I get 40 on 9. So what can we take out? We can take out, can you simplify it? Okay, we can take out 20 on 9. So I'd got 20 on 9. then I'd get 2, 2, and negative 1. Is that there? 20 on 9, 2, 2, neg 1. That's there. That's it. So on the CAS, you can see I did the dot product of the original vector with the unit vector, and then I multiplied it by the unit vector again, which is what we do to find the thing in that direction. Okay, this one looks like fun. Let OA be CD. Okay, so there's O, be a right square pyramid. OA is A, OB is, stupid thing, OB is B, OC, surprisingly, is C, OD is D. Okay, this looks like it's going to be fun. What do I know? A plus C, A, that one there, plus C, that's going to bring me out there. That's the same as B. Oh, hang on. C is going the other way. I stuffed that up. So C is going downwards. So that would actually be A and then plus C, which would bring us down here. So it's going to be directly below. And what was the other one? The next one's B plus D. So B plus D, that's going to bring us to the same thing. So an equation quickly relating, that one is correct. Yeah, we hit that one on the nail straight away. Okay, given those vectors are linearly independent, find the value of lambda. Okay, so I'm going to say A, 1, 1, negative 1, M plus 2, negative 1, 2, N is equal to lambda, negative 1, 4. The only ones I care about at the moment are the bottom ones. So M minus N equals negative 1. Negative M plus 2N is equal to 4. They're linearly dependent. So if we add them together, we get N equals 3. If we sub that back in, I get M minus 3 is equal to negative 1. So from here, M is equal to 2. So in the top equation, I get M plus 2n is equal to lambda. If we sub those values in, 2 plus 2 times 3 equals lambda, so lambda equals 8. Okay, a particle of mass 2 kilograms has an initial velocity of that. After a change of momentum, okay, so a change in momentum is P final minus P initial. To work out our momentum, it's our mass times our velocity. So a change of momentum of that. So our change in momentum is this, 6i minus 2j. That's equal to the particle's velocity. So we've got to find our final velocity. Our final velocity, our final velocity. Our momentum is mass times velocity, so it's going to be 2 times v. That's what we're trying to find. Minus our initial velocity, which is 2 times that, which is 2i, and then minus 12. I've got j. So we know 2v is equal to, okay, if we subtract that from here, let's bring it to the other side, we're going to get 8i when we bring that over. That's going to be plus 12, bring it to the other side, it's going to be minus, so it's going to be minus 14j. So therefore v is equal to 4i minus 7j. And there's an answer there that looks like that, so it seems good. A person of mass, m kilos, is carrying a bag of mass m kilos, little m, standing in a lift that's accelerating downwards. So the lift's accelerating downwards. There's the little man holding his little bag. Okay, So downward, we've got the man's m plus m times g. Standing in a lift that's accelerating downwards, the force of the lift floor on the person has magnitude. Okay. So the force is going upwards. So downwards we've got big M plus little m g minus our force. That's equal to our acceleration, which is our mass, which is big M plus little m times A. The force of the floor, okay, so we'd bring that to the other side. So we'd have m plus mg minus m plus ma is equal to F. So we can take out big M plus little m g minus A is equal to F. Is that there? It is. That's always good. The acceleration of a particle moving in a straight line is given by that, where the velocity... The initial velocity of the particle origin is 2 meters a second. The displacement of the particle from... Okay. So first thing, we know that v dv dx is acceleration, and that's v squared plus 1. So dv dx is equal to v squared plus 1 on v. Let's flip it upside down. dx equals v on v squared plus 1 dv. X is therefore equal to, remember you don't have to show you're working because this is a multi-choice. So I want to put a 2 on top, 2v on v squared plus 1 dv. So I'm going to put a half out the front. When I integrate it, I get x equals a half log e mod v squared plus 1 plus c. The initial velocity of the particle when at the origin is 2 meters a second. So when x equals 0, v equals 2. 0 equals 1/2 log e mod 5. The displacement of the particle from the origin when its velocity is 3 meters a second. Okay, so that is c. c is negative 1/2 log e 5. The displacement of the particle, so I want to find x. We know that that's a half log e of 10, because v squared, which is 3 squared, plus 1 is 10, and then minus a half log e 5. Can't get a 5 in there. Okay, so that's going to give us a half log e of 10 on 5, which is a half log e 2, which is there. Don't forget you can divide them. We're nearly there. Okay, x is a random variable. Standard deviation 5, or with mean of 5 and a standard deviation of 4. Y is a random variable with mean of 3. Okay, so let's say mu x is 5, SD of x is 4, mu y is 3, and then SD of y is 2. X and y, z equals then the mean and standard deviation. Okay, so E of z is E of x minus 2y, which is E of x minus 2 times E of y. E of x is 5 minus 8, that's minus 3. Did I stuff something up? What did I stuff up? Oh, look at the right thing. Okay, so we've got 5 minus 2 times 3, which is 6, so we're going to get minus 1. Now, our standard deviation is... Well, first we've got to find out our variance. So our variance of x minus 2y is var of x minus var of 2y, which is var of x minus 4, because you've got to square it when you bring it outside. Var of y. Okay, what's var of x? That's 16. Minus var of y, which is 4, times 4, which is 16. That doesn't sound right, does it? Oh. That's a plus, because that's a plus and that's a minus, and when I bring it out the front it becomes 4. So I get 16 plus 16, which is 32. Okay, from there, var of z is the square, standard deviation of z is the square root of 32, which is 4 root 2. Negative 1 and 4 root 2 is b. Looks right. Petrol consumption of a particular model of normally distributed with a mean of 12 and a standard deviation 16 cars exceeds that. Okay, so x bar is equal to 12 SD of x bar is equal to 2. The probability that the average consumption 16 cars, so n equals 16. Our standard deviation is going to be, no, that's just the standard deviation. It's not the standard deviation of x. The standard deviation of x is 2 on root 16, which is 4, which is a half. Okay, and we want to go, probably the x is greater than 13. So, normally distributed. Let's clear all this. Interactive distribution, continuous, norm CDF. Our lower is 13. With norm, we always go to infinity. Our standard deviation was a half, and our mean was 12, if I remember correctly. Yep. Okay, 0.228, which is there. 0.0228. Okay, the mass of suspended matter. Code is normally distributed on the mean. Standard deviation. Okay, mu. Standard deviation sigma equals 8. The mean of 100 40. So the mean x bar is equal to 40. Based on this 90% confidence interval for mu. Okay, so we don't know what mu is, but we want to find out a confidence interval. So x bar is that 100, so n equals 100. Okay, so we're going to use one sample z interval on our cas. So go out of here, calc interval, because we want an interval. One sample z. It's a sample because there's 100 people. Now it was 90%, wasn't it? Our standard deviation was 8. Our sample mean was 40, and we had 100 people. Now don't put in your sample standard deviation. You've got to put in the population standard deviation, and it'll actually calculate the sample based on n. Okay, so 38.68 and 41.31. 38.68 and 41. Did I get that wrong? 0.32. Yep. Okay, so that's it. So that's part 1 of exam 2. Part 2 you can go to next if you want and have a look and see how to finish off the exam and hopefully get it done in 2 hours. Good luck.